Okay, let's unpack this hypothetical. Imagine waking up tomorrow and the big news is Yellowstone. Not just, Old Faithful acting up, but something really big brewing.
Yeah, exactly. We're talking about a potential super eruption. It's the kind of event that, well, it could genuinely reshape life as we know it.
So today, we're doing a deep dive into that, looking at the science, the potential fallout, based on what researchers are discussing.
And the goal here isn't to scaremonger, right? It's about understanding the reality versus maybe the movie version of things, giving you, the listener, a clearer picture.
Absolutely. No doom and gloom prophecies, just
Right.
what does the science actually suggest might happen. So first things first, Yellowstone. What makes it so super compared to a regular volcano?
Well, the whole park, Yellowstone National Park, it basically sits inside a giant volcanic caldera. It's the remnant of a truly colossal eruption, the last big one being, around 640,000 years ago.
640,000 years. Okay.
And when we say supervolcano, the definition involves ejecting over 1,000 cubic kilometers of material.
1,000 cubic kilometers? That sounds like a lot. How does that compare to something people might remember, like Mount St. Helens?
Right, so Mount St. Helens in 1980, that was about 1 cubic kilometer.
1 versus 1,000.
It's completely different scale. We're talking ash clouds potentially reaching, say, 30 kilometers up.
Way up into the stratosphere.
Exactly, high enough to spread ash across continents.
Continents, wow. So what would that look like, practically, say, here in the U.S.?
Well, the models suggest the Midwest could get several inches of ash. Maybe more.
Several inches covering states like Nebraska, Kansas.
Potentially, yeah. And what's really striking is even places far away, like New York, could still see a measurable dusting.
Even on the East Coast.
But obviously, the immediate vicinity is where it's truly devastating. Anything within, say, 100-mile radius.
Like Bozeman, Montana?
Yeah, places like Bozeman, they could be looking at being buried under feet, possibly many feet, of ash.
Buried. Just gone under ash. That's hard to picture. And the ash itself, it's not just like fireplace soot, is it?
No, not at all. It's basically pulverized rock and glass. Very fine, very abrasive. It gets into everything. Clogs engines, air filters. It would ground air travel instantly.
Okay, so transport shuts down.
Roads would become incredibly hazardous, maybe impassable. The weight of the ash, especially if it gets wet, can collapse roofs.
Right.
And power grids are really vulnerable. The ash conducts electricity when wet, causing short circuits, transformers blowing, widespread blackouts.
The water supplies.
Contaminated. The ash would get into reservoirs, rivers. It's a complete infrastructure nightmare, really.
So it's not just the eruption zone. It's this creeping paralysis caused by the ash spreading out.
Precisely. And that's before we even get to the longer-term climate effects.
Yeah, let's talk about that. The volcanic winter. How does that work?
Okay, so the eruption doesn't just throw ash up. It also releases enormous amounts of sulfur dioxide gas, SO2, way up into the stratosphere.
Higher than the ash cloud even.
Yeah, it gets into that stable upper layer. And up there, the SO2 reacts with water vapor to form tiny sulfate particles, or aerosols.
Okay, sulfate aerosols.
And these aerosols are really good at reflecting sunlight back into space.
So less sun reaches the surface, like pulling down a global shade.
Kind of, yeah. The effect is a drop in global temperatures. Estimates for a Yellowstone scale event are maybe 3 to 5 degrees Celsius cooling, globally average.
3 to 5 degrees C. That sounds like a lot. Do we have any historical comparison for that kind of thing?
We do. The 1815 eruption of Mount Tambora in Indonesia is the classic example.
Right, I've heard of that one.
Tambora was big, but still considerably smaller than Yellowstone's potential.
Sure.
Yet it led to 1816 being called the year without a summer.
Why? What happened?
Widespread effects. Snowfall in June in New England, for instance. Massive crop failures across Europe and North America. Famine, disease. It was a major global crisis triggered by that one eruption.
And Yellowstone could be worse.
The potential is certainly there for a more severe and maybe longer-lasting cooling period. The impact on agriculture, food supplies, it would be immense.
That's pretty sobering. Okay, so bringing it back to the present, what are the actual odds of this happening, like tomorrow or next year?
Well, statistically speaking, the probability of another super eruption in any given year is extremely low, like really low.
How low are we talking?
The USGS often quotes odds like 1 in 730,000 annually. Yellowstone is active, mind you. It has thousands of small earthquakes every year.
Around 1,500 to 2,000, right? That's normal.
That's considered normal background activity for the Caldera system, yes.
How long?
And all the current monitoring ground deformation, gas emissions, seismic signals, it doesn't suggest a major eruption is, imminent. The magma chamber doesn't seem to be acutely pressurized right now.
Okay, statistically unlikely.
Yeah.
It's good to hear. But geology isn't always predictable, is it? There have to be uncertainty.
Oh, absolutely. Predicting these things with certainty is incredibly difficult. We're looking at processes happening deep underground, maybe 8 kilometers down or more.
Right.
We monitor the surface expressions, the ground rising and falling slightly over years, changes in geysers, earthquake swarms. These give us clues. But it's like trying to understand exactly what's happening inside a giant, complex machine just by listening to the noises it makes and watching the casing bulge slightly.
So we're listening, watching, taking its pulse. But we can't see the whole picture deep down.
That's a good way to put it. The forces involved are immense, and the exact trigger for such a massive eruption isn't perfectly understood.
Okay, so if things did start changing, if an eruption was actually starting to build, would we know? Would there be warning signs?
Almost certainly, yes. We'd expect to see significant changes in the monitoring data. Things like a dramatic increase in the number and intensity of earthquakes.
More than the usual background noise.
Much more. And changes in the type of earthquakes, perhaps harmonic tremors, which are associated with magma movement. We'd also likely see much faster and more pronounced ground uplift or deformations.
Ground physically swelling.
Yes, indicating pressure building below. And changes in the gases being released from fumaroles, maybe more sulfur dioxide. These signals together would be a strong indication something was happening.
Right, a whole cluster of warning signs. But the crucial question is, how much warning? Are we talking weeks, days,
Right.
or could it be much faster?
That's the big unknown, really. In some scenarios, you might see escalating activity over weeks, maybe even months, which would hopefully allow for warnings and evacuations, at least for the immediate areas.
Okay, that's somewhat reassuring.
But it's also possible that the final, critical stage could accelerate very rapidly. Some models suggest the tipping point could be reached quite quickly. So in a worst-case scenario, the definitive warning might only be hours.
Hours. Wow.
Yeah.
There's not much time for an event of this scale.
No, it's not. And understanding that progression is a major focus of ongoing research.
Okay, so let's address the elephant in the room, maybe the biggest fear people have. Would a Yellowstone super eruption mean the end, like human extinction?
Okay, that's a common question. And the scientific consensus is pretty clear. No, it would not cause human extinction.
Not extinction, no.
Humans are incredibly widespread across the planet. We're adaptable. While the eruption's impact would be catastrophic regionally and the global climate effects severe and long-lasting, it wouldn't wipe us out as a species.
But you did say earlier it could bend or break civilization as we know it. What does that look like if not extinction?
It means our complex, interconnected global systems would be massively stressed, perhaps beyond their breaking point in some areas. Think about it. Widespread, prolonged crop failures leading to global food shortages. Breakdown of transportation networks, energy grids, communication systems due to the ash and potentially the climate effects. This wouldn't be a sudden apocalypse movie scenario, but more like a slow-motion global crisis.
Oh, a really, really challenging period of adaptation, hardship, societal disruption.
Exactly. Massive upheaval. Recovery would be possible, but the world on the other side might look very different. And it's worth remembering, scientists generally agree the question isn't if Yellowstone will have another major eruption, but when.
But when could be thousands or tens of thousands of years from now.
Or longer, yes. The geological timescales are vast. It's highly unlikely to be within our lifetimes or even our grandchildren's lifetimes based on current understanding.
Right. So wrapping this up then. Yellowstone is this immense geological feature, a supervolcano capable of, well, almost unimaginable power.
Capable of blanketing much of North America in ash and triggering a significant volcanic winter globally.
But the odds of that happening anytime soon are very low, statistically speaking, though there's always that inherent unpredictability with geology.
Precisely. And if it were to happen, the warning signs might exist, but the lead time is uncertain.
And the consequences. Not extinction, but profound challenge to civilization, a potential reshaping of the world.
It really underscores the sheer power of the planet we live on.
It certainly does. And that leaves us, and you, the listener, with something to think about, doesn't it? Given this potential, this immense power lying beneath a place like Yellowstone, even with the low probability in our time, what does it mean to live alongside these kinds of forces? How do we balance our scientific knowledge with the fundamental uncertainty of nature on this grand scale? It's definitely food for thought.